probabilities from two-way tables. Honestly, I find this stuff fascinating because it is such a great way to stop a thinking error that so many people have. So many statistics in the news make this error, people talking on talk shows make this error, and people day to day make this error all the time. And it's a problem in their thinking. And I'll show you the error right at the end. The question here that we want to find out is, are pet owners more likely to be happy? Maybe you have your own intuition about whether you think that's true. So we do a survey, and a survey asks 20 people 2 questions. Do you have a pet, and do you feel happy today? And this data is made up. I made this data up. And we've got the results here. We've sorted it into whether they own a pet, yes or no, and whether they are happy or unhappy. Before analysing this data, let's try to understand it. This 2 represents that 2 people are happy today, but they do not have a pet. The 4 means there are 4 people who are happy and have a pet. There are 13 people who are unhappy and have a pet. Now that we've got an idea about what these numbers mean, we can start getting some probabilities from this and noticing trends. But before we do that even, it's helpful to know the total number of happy people and the total number of unhappy people and so on. So the total here, this total, is going to be the sum of these 2 numbers. And 4 plus 2 is 6. The number that goes here is the sum of 13 and 1, which is 14. The number here is 4 plus 13, which is 17. This is 2 plus 1, which is 3. This number here, you could do it one of 2 ways. You'll get the same answer. Unless you've made a mistake, you'll always get the same answer if you add it up this way or this way. You'll get the same answer. So what number goes here? This is 20. And this is always the total sample size. It's the number of people that you asked, for example, which is 20. All right, let's estimate the probability that a randomly selected person has a pet and is happy. So pet is yes, and they are happy. How many people out of these, how many people have a pet and they are happy? 4. 4 people say, yes, I have a pet, and yes, I am happy. 4 people out of how many in total? Notice that I am randomly selecting anyone. I'm randomly selecting someone from the whole sample. So how many people in total did I ask? 20. I asked 20 people. I can write this as a probability like this. I can say therefore, so I've got this, therefore, so because of that, this is true. The probability of being a pet owner and happy. You might remember this symbol from Venn diagrams. It's the area in the middle. It's called the intersection. The area in the middle is that symbol. The intersection. In probability, we can treat it as the word and. The probability that this is true, they're a pet owner, and they are happy. It sort of looks like an A, doesn't it, for and? All right, so the probability of being a pet owner and happy is, well, we can write this as a fraction. 4 out of 20. We could also write this as a percentage. To get this as a percentage, you put it in your calculator and times by 100 and put a percent sign at the end. So what is this as a percentage? It's 20%. 4 divided by 20 is 0.2 times 100 is 20%. All right, let's estimate the probability that a randomly selected person from the whole group has a pet. Looking at this data, how many people have a pet? I don't care if they're happy or unhappy. How many people have a pet? There are 17 people who have a pet out of 20 in total. 4 of those 17 have a pet and are happy, 13 have a pet and are unhappy, but there are 17 people who have a pet. So that's 85% of people have a pet. Again, this data is not real. I made it up. Finally, what is the probability that a person feels happy today given that they are a pet owner? Another way of phrasing this is I randomly pick a pet owner. Assume that someone is a pet owner. I have randomly chosen one of these people. Not someone from the whole group. I've randomly chosen someone who owns a pet. First of all, how many of these people in here are also happy? There are 4 people out of these people that own a pet that are also happy. Okay. Now it says given that they are a pet owner. So I'm not picking a random person from the whole group. I'm only picking a random pet owner. So I'm starting with this group of people, 4 out of 17. Do you notice the difference between this question and this question? I'll just get rid of some of the scribbling here. In this question, I randomly pick a person from the whole group, but here I'm randomly picking someone who is a pet owner. I'm ignoring all of the people that don't own pets. So that's why the total that I'm looking at it out of is different. All right, so with that established, let's move on. We can write this as a fraction. You might be confused how to write the probability phrase in here. How do you word this? You could just do probability happy today, given that they are a pet owner. But that's a lot of writing, and mathematicians are very lazy. So we can say it like this. Therefore, the probability of being happy given that. This line here means assuming that someone is a pet owner. I randomly pick someone who I know is a pet owner, and out of those people, how many of them are happy? That's what this line means. It means given that. All right, so probability of being happy given that they're a pet owner we've got here is 4 out of 17. I can calculate this as a percentage, which is rounded off 24%. So if you randomly pick someone who is a pet owner, there's a 24% chance that they're happy. Now, this is where some people go wrong with a thinking error. They say something like this. Like you might see a news article like this, or I don't know, maybe people just chatting to each other about this. This can even be, a racial discrimination thing or a religious discrimination thing. If you substitute the kind of categories here with particular races or religions, people can make big thinking errors that have consequences in their lives and for those around them. Anyway, someone says something like this. Look at all of the happy people. Look at these happy people. You look at the happy people in this population, or in this sample, I should say. Most of these happy people own pets. 4 out of 6, 2/3 of the happy people own pets. Most of the happy people own pets, that's true. Therefore, pet owners are more likely to be happy. They're happier on average. What do you think of that? Is there something wrong with this reasoning? The thing that's wrong is, yes, most of the happy people are pet owners, but also most of the unhappy people are pet owners as well. In fact, most of the people are pet owners. 17 out of 20, 85%, most people are pet owners. So yes, if you look at the happy people, of course most of them will have pets. You'd expect that because most people in the sample have pets. And in fact, if we look at it, the pet owners, most of the pet owners are unhappy. There's only a 24% chance. If you pick a pet owner, there's a pretty small chance, it's unlikely, that they're happy. Whereas the people who don't have pets, look at them. Most of the people who don't have pets are happy. 2/3 of people who don't have pets are happy. There is a name for this. It's called the base rate fallacy. I find it really interesting. As an analogy, like, look at this. Look at the happy people. Most of them are right-handed. Therefore, right-handers are more likely to be happy. No, that doesn't follow. Because most people in the world are right-handed. So of course, most happy people are right-handed. The way to get around that we don't cover much in Year 8, but if you're interested, The way we get around that is given that. Out of the pet owners, what percent are happy? Out of the non-pet owners, what percent are happy? All right. I hope you found this topic as interesting as I have. There's a little bit more in it, but please have a go at the questions and let me know if you need a hand. Bye, everyone.